Okay, welcome back. So the key now is to set equation 1 equal to equation 2, since they're both equal to r squared. So I will have the quantity -7 minus h squared plus 2 minus k squared, and I'm setting that equal to the second equation, -5 minus h squared plus the quantity 4 minus k squared, keeping track that I'm using equation 1 and 2. Now I need to multiply this out. These are a bunch of binomials. We want to make sure we don't do any illegal math. So we're going to write out the binomials, okay? And make sure that you are being super, super careful. Make sure you are writing out the binomials properly so that you can easily distribute and combine like terms. Also make sure you're keeping track that I'm not making any mistakes. Okay, so now let's distribute. So this is going to be positive 49 plus 14h plus h squared plus 4 minus 4k plus k squared is equal to positive 25 plus 10h plus h squared, okay, plus 16 minus 8k plus k squared. Okay, again, double check my work. Now, what's cool about this problem is you'll notice that the h squareds on both sides can actually cancel. The k squareds also cancel. And what we can do is try to bring everything over to one side. So let's look at all the numbers first. I have 49, 4, so that's going to give me 53. And then over here, I have 25 plus 16, which is 41. If I take 53 minus 41 on the left-hand side, that's going to leave me with a 12, okay? So now let's clean everything else up. Let's look at all the h's. So I have a 14h and I have a 10h. If I subtract the 10h from both sides, that leaves me with positive 4h. And then finally, I'm just going to bring everything to the left. If I look at the k's, I have a negative 8k. If I add that to both sides to become a positive 8k, I'm going to get a positive 4k on the left, and that's going to all equal 0. And what I can do with this equation is divide every term by a 4 just to make it easier. Okay, and I'm now going to have 3 plus h plus k equals 0. All right, and this is one equation with two unknowns. So this needs a friend. Now, to get this equation, we used equations 1 and 2, okay? So what that means is we must use equation 3 next. And what I think I'm gonna do, just to keep things easy, is I'm gonna use equations 1 and 3, okay? And I'm gonna set 1 equal to 3. Now, since 1 has already been multiplied out here, I'm just gonna literally like recopy that. Okay, because it's like I would have set 1 equal to 3, I would have multiplied all that out. So that's going to be 49 plus 14h plus h squared plus 4 minus 4k plus k squared. Okay, now that is going to equal equation 3. And equation 3, remember, is up here. And so this is 5 minus h squared plus 2 minus k squared, okay? I'm not setting it equal to r squared because this is r squared, so r squared equals r squared. So we're gonna multiply this out. Let me recopy and show all my work and double check as you go along that I'm not making a mistake, okay? So I have 49 plus 14h plus h squared plus 4 minus 4k plus k squared, okay? Now in theory, you're gonna write these binomials out. You're gonna distribute and combine like terms. When you do that, you should get 25 minus 10h plus h squared plus 4 minus 4k plus k squared. And if you need to pause the video and just double check my math, I will not be offended. So make sure that you think that I did not make a mistake. Again, you'll notice the h squareds and the k squareds cancel, and we can do similar logic. We're going to put all the terms on the left. So I have 49 plus 4, that's 53, but I'm going to subtract a 29, and that's going to give me 53 minus 29 is going to give me 24 on the left-hand side. Okay, then I'm going to get all the h's together. So I have 14h here, I have negative 10 here. If I add the negative 10, I'm going to get positive 24h. And then finally, the k's, it's kind of interesting. The negative 4k and the negative 4k will actually cancel. And again, to make this easy, I'm dividing every term by 24. This is totally legal and a good idea. So this is actually pretty easy now. I have these two equations, right? I know 1 plus h equals 0, so I know h is equal to negative 1. And now that I know h is equal to negative 1, I can plug that back in up here, and I know that k, right, this would be negative 2, would be equal to negative 2, okay? So this is kind of neat. Now that I have this figured out, the only thing I need to solve for is r, and then I can plug these back into my original equation or any equation in standard form. So all I need to do is find r, okay? And if you look, you can pick, I don't know, it's probably easier to pick either equation 1, 2, or 3. I'm going to pick equation 3. I'm going to plug the h and k in here, and I'll get r. So let's do that. So h is negative 1, so this is 5 plus 1 squared, okay? K is negative 2, so 2, that's going to be plus 2 squared equals r squared, okay? And this is going to be 36, I'll put that here, plus this will be 16, and that's going to be 52. So I know that r squared is equal to 52. R squared is equal to 52. And now I have solved my mystery. I can substitute all of my information into the standard form. So this is x minus h, so x plus 1 quantity squared, plus y minus k, so it's plus 2 quantity squared, equals r squared, which is 52. And anytime you need to solve a system of 3 equations and 3 unknowns, I highly recommend you do this method. In the practice, you're going to see problems number 35 and 36 are very similar. On a quiz or test, I will expect you to do this by hand without a calculator. Even though you can use a calculator to assist you, I'm going to want to see all of this work. And if there are any more practice problems that involve solving a system, this is the video I would like you to reference.